This is the Cary 6000i UV Vis near IR detector. So for the UV Vis, you turn the instrument on and allow the bulbs to warm up for about 20 to 30 minutes. Typically this computer is left on, the one attached to the UV Vis, so you would, once you get your login credentials, just log in. At this point it will start Windows, and if you don't have the scan icon on your desktop, you can find that through the Start and then Programs menu. So as I mentioned earlier, we came in about 20 to 30 minutes prior to our experiment. We turned on the instrument, let it wind up. Now obviously we've logged in and we've started the scan program. For the UV Vis, typically the disposable cuvettes are used, and you can use those one time and throw them away. They are made out of a polymer, so they are fine for most aqueous-based solutions. If you do need quartz for an organic that would dissolve that, you can use these, and after you get training we'll show you where these are for access to these. But these, if we've used over and over, so they may need to be washed out. So if you do need to use these, you can rinse with an alcohol. IPA, isopropyl alcohol, or methanol is fine. You can rinse it and then just pour it in a waste container, and then typically blow it dry with nitrogen, which is on the tabletop benches. So that's the way I would clean this if I was going to use the quartz cuvette. Today we're just using food coloring, so we'll use the disposable ones in the video. So I'm showing 3 cuvettes here because typically you will do 3 things. You will take a 0, which would be this cuvette here with nothing in it. Then you would take a blank, which has just your solvent. So in the case today, it's water. So this would be our baseline. And then our sample. So our sample is just red food coloring and water. And that's why cuvette number 2 had water in it, because that's just the solvent. So what I'm showing here is 3 cuvettes. The 0, the blank, the sample. So this one has to be the same solvent as this. So if this food coloring was dissolved in ethanol, this would be pure ethanol. Some people, if they want to be very picky, especially using these disposable cuvettes, they would use the same cuvette for all 3 of these, right? So they'd pick one cuvette, do the 0 with nothing in it, then put in the solvent, so water, and do the baseline or the blank, and then use the same one after you've poured the water out to do the sample. So in that case, I guess it would be a little more accurate because you're using the same glass and the same cuvette for each one. So the first thing we would do is actually set up the instrument. So if we go to Setup, you have a bunch of tabs up here, and you can define the wavelength range. So from, this is already set up as 200 nanometers to 800 nanometers. And I think you can even change it to wave numbers, angstroms, or angles. So we'll leave that in nanometers and stay through this whole visible range. Then if you go to options, you can set up the instrument either in double dual beam mode or single front. So as you'll see in a second, there are 2 paths for the beam, and if we leave it in double, you can have a reference in the back and your actual sample in the front. So we'll do single front just for today, so I can show you the actual exchange of each sample and blank one by one. The baseline, typically 0 and baseline correction is what's recommended. And then that's all we really need. We can click OK. So now what we would do is load in the empty cuvette. So if we hit 0, it should walk us through it. So if we hit 0, it says load blank, press OK to read. After clicking 0 on the instrument, we will load a blank cuvette. And the disposable cuvettes have a triangle shape on one side. I always load that to my left so that the path of light goes this way. We chose single front as opposed to dual beam, so we won't use the back one, we will only use the front one. So we load in a blank cuvette and then close the door. So now that the blank is loaded into the instrument, we'll click OK. And now what we can do is actually take a baseline. So if we click baseline, tells us insert a blank sample into the compartment and press OK to collect the 100% transmission baseline scan. After clicking baseline, it asks us to load a solvent-filled cuvette and load it into the single front. So he's loaded the same way, and we close the door. So now we have our solvent and the cuvette loaded into the compartment, the front compartment, and we'll click OK. So that will take our baseline. So now it asks us to block the sample beam and press OK to collect the 0% transmittance. So we will open and remove the solvent-filled cuvette. And typically we just block the path with this piece of cardboard that's been taped with black. So you can see that we'll just place it right in front of the optical path, and it does block the path. So we'll close the door and then click OK. Now the baseline's been established. When we've collected the 0% transmittance, we can remove the black card and load our sample. Our sample today, like I said, is just red food coloring. And the triangle, I would make sure that's facing towards the left. And then we could load the sample. Close the door. Now that we have our sample loaded, we can just click Start. And we can name it. So we'll find the folder that we want. And we'll name that today's date, which is, and that is red food coloring. Click Save. This is the first sample that we will run. Click OK. Now it asks us, do we want to run another sample? You could, just click OK, but we'll do Finish for today. So what we have on the screen looks kind of like a mess. You can click this first icon and define what you want to see. So we just want to see the sample, so we'll get rid of that 0% baseline transmittance and the 100% transmittance. If we get rid of those, we'll see our sample that has been corrected for the solvent. So we click Apply and then OK. Now we've got this, and what we're looking at is red food coloring. So we can adjust the axis between, let's say, 350 and 700, because that's the visible range. So we can right click and go to Axis Scale. And like I said, we will just let's do 400 to 700, right there in the visible range. And then I can see that our peaks are going to be right between 0 and about 1. So let's define the y-axis as well. So we'll go from 0 to, we'll do 0.75. Let's see what that looks like. And click OK. All right, it's a little too high, so let's right click again, go to Scale Axis. Let's do like 1.25. OK. Now, that's what we expect to see for red, right? What we actually see is in this range, so it did not absorb there. And then it did absorb for the meat, or the good portion of the rest of the visible wavelengths. So this is what you would expect for red food coloring. At this point, you can go to File, Save Data As, and you can save it as a number of different files. People commonly do the .csv, comma, separated values. That way you can import that into an Excel spreadsheet. So that's what we'll do. So we'll just label it my name for today. and then we will do comma separated values, click save, and now if I wanted to, I can import that into Excel. So that's basically it, except for the cleanup, which I'll show you next. For the disposable cuvettes, just pour your sample into a waste container and then they can be thrown away. If you did use some kind of hazardous solvent or organic solvent, make sure it's disposed of properly. So this has a little bit of red food coloring. I'll just wash that out with water or an alcohol and then dispose of it. If I did use the nice quartz cuvette, make sure at the end he gets rinsed with alcohol, so IPA, methanol, and then blown dry with either nitrogen or the house airline is fine. To shut the program down, make sure your files are saved, which we've already done. Then you can close out of the program and then make sure you sign out or log off. And we typically leave this computer on. So once you signed out, you will turn the instrument off on the front panel, and that's it.